Hi everyone, my name's Titus, and today we have another Hexagon-based grid system tutorial, and in this video we're going to be demonstrating the PointyTop orientation for the setup. Let's not waste any time and jump right into it. Alright, so let's hop into Blender. We have our default scene. We need to make a quick hexagon, so let's delete the cube here. We'll press Shift A, we're going to add a mesh, choose a cylinder. We'll go to the cylinder properties, we'll set the vertices to be 6. And we're going to set the depth to be 0.25. And then for the rotation, we need 90-degree rotation, so the pointy top is facing forward along the x-axis, kind of like so. We can press tab to go into edit mode. We're going to select face select here, and we can select this top face and press I to add an inset. Click to set that, and then you can press Alt S and then just push up to give it a little bit of definition. I think it looks good. With our hexagon selected, we can go to File, Export, choose FBX. We're going to pick a location, and then I'm going to call this the Hex Pointy Top. I'm going to limit this selection to be only selected objects, and then for the transform, I'm going to adjust the forward to be the X positive and the up to be Z positive, and then hit Export. We're done with Blender. We can go back to Unreal Engine and we can import our static mesh. We just highlight our pointy top that we just created, drag it in, and then hit Import All. And then that'll give us our mesh that we can build off of. Let's go ahead and create a new level. We'll use a basic level template and then hit Create. I'm going to select the floor and delete it. And I think that'll be good for starting off. Let's right click and create a new blueprint. We'll choose of type actor, and we will call this BP underscore hex underscore pointy top. We can then double click to actually open this up, and then let's dock it in our main window here. Now the component that we need is going to be an instance static mesh here. So we can click that. And I'm going to leave the default name alone and just hit enter. We're going to need 4 functions. So under the function section, we can hit the plus sign. The first function we'll call is going to be calculate sizes. The second function we need is the horizontal space function. And then we also need a vertical space function. And then last function we need is a offset hexagons function. With our functions defined, we can actually start creating our variables. So we'll hit the plus sign next to the variable. First one we'll create is a radius small. We're going to set the data type to be a float. And then we'll hit the plus sign and we're going to create a radius large. And then we need to create a diameter small. And then a diameter large. Oops. And then with that, we will also need some public facing variables to adjust the hexagon grid's offset and kind of size. So we'll create one called offset. We'll create another one called scale. And then our last float variable that we need is going to be a row offset. Now we need some integers. I'm going to label mine as the height and width, but you can also use row or column, kind of whatever you want to call it. All right, the second one's going to be a width. And then the last variable we need is going to be a static mesh that we'll call tile mesh. Now for the data type, you simply want to search for static mesh. There'll be a little expand box here under static mesh. You're going to choose the object reference. And then we can make the tile mesh the height and width, and then the scale and offset public facing variables. So you can click the little eyeball there, or you can select them and check the box for instance editable, whenever you prefer. When you hit compile and save, we'll actually open up the properties panel so we can actually set some default values. For the tile mesh, we can use our hex pointy top that we created in Blender. For the height and width, I think a default value of 10 starting off is good. You can adjust these on the fly, of course, in the editor. And then the other one we need is the scale. If you leave the scale to 0, your grid won't show up. So let's use a default of 1 starting off. All right, let's come to our construction script. We won't need the event graph, so I'm just gonna close out of that for now. We can pull into this into a set static mesh. And then the reference will be the instance static mesh, which is this component that we added earlier. And then we can plug in our tile mesh variable into the new mesh section here. And then we can pull into our first function, which is the calculate sizes. And then we can call into our first for loop. Our for loop should start at 0, and then the last index should be the height. So we can just drag this into last, and that's good here. Now this loop condition should actually check the run the horizontal spacing function. So we can just pull off this into horizontal space. And then after that, we can pull into our last for loop. First index is going to be 0, and then the last index on this one is going to be our width. Like so. The loop body of this one is going to be checking our vertical space function. And then after that, we can simply call into the add instance. And make sure you use the singular one, add instance, don't do the add instances. We'll want to split the transform, so right click and split it. And then we can right click and split the location, because we're only going to be setting the X and Y, we're not going to be working in the Z. Now for our scale value down here, we can simply plug in our scale variable, and that'll make the necessary conversion for us. And this is the skeleton of our construction script. So now we can begin setting up the functions. So the first function we can do is the calculate sizes function. It's a little bit long, so we'll drag in the tile mesh. What we need to do is we need to call into the get bounding box. And then we want to split this return value. And then we want to split the return value max. We don't need to do that on the min because we're not going to be working with the min values. The reason we're not is because these are negative values. So this function is going to be calculating the 2 radii and the 2 diameters. If we go back to our folder structure here, and we'll go to top view, open up our static mesh, and we could show the bounds here. Now for a hexagon actually has a small radius and a large radius. The small radius is going to be on the flat side of the shape. The longer radius is going to be on the pointy side of the shape. So because it has 2 radii, it means there's 2 diameters. Now if you look in the bottom left gizmo, you can see our left and right is our x-axis, and then our up and down is our y-axis. So green is y, red is x. So looking at this shape, you can see that on the x-axis is our larger radius, and on the y-axis is our smaller radius. So when we go back to our blueprint, we'll want to first set our small radius. This is actually going to be using the y value. So what we can do is, since we're using a scalar, we will multiply both the x and the y by our scale value. And then because when we go back to our shape, we can see that the y has the smaller radius. We will plug in the y value max for the radius small. We can then take that value and multiply it against 2, and that'll give us our small diameter. So we can hold Alt, drag this in to get a setter. we can hold Alt, drag in our large radius, and that'll be the X value. So going back to our shape, you can see the X axis has the longer radius. So we'll plug this in over here. And then we can pull into a multiply node, just like before, multiply it by 2, which will give us our large diameter. We can hold the Alt key, drag that in to get a setter. And then this will complete our calculate sizes function, basically. So the next function we can write is our horizontal space. We need to select the purple node, add an input pin. The input pin we can call hex number. We'll set that to be an integer. Then we need the, so the way you can cut in the PointyTop orientation, the horizontal is basically, the horizontal spacing is equal to the square root of 3 times the radius small, so the small radius in this case. But we're going to also multiply that against our offset, so we have the ability to offset these tiles in the editor if we want to. So we'll get a call to the square root, pop in 3 there, and then we can pull into a multiply node. I'm going to hit the little plus sign to add another pin, and I'm going to drop this down 1, and then I can take my radius small, drag this into here, and I'm going to drag the hex number into here, and now I just need my offset. So I can hold Control, drag in the offset, pull into a multiply node, and we can drag this into here. And these can come into a simple add node. And then we need to return this value, so I'm just going to drag it into this purple node. It'll automatically give me a return node, and then I can just pop this into here, like so. And that'll basically complete the horizontal function setup. So let's go to the vertical space. We're going to do something similar. So in the PointyTop configuration, the vertical spacing can be calculated by 0.85 times the height, which in this case would be the large diameter, because we rotated ours. So under the vertical space, we're going to hit the input, and this is going to be the hex number. Oops. And then we can basically get the large diameter. So hold Control, drag this in, pull into a multiply node. Again, we're going to hit the plus sign to add a pin. I'm going to drag this in over here, plug the hex number in there, and this value is 0.85 that I found lines up pretty good. And then we need the offset as well. So we'll hold Control, drag in the offset, and then we'll pull into a multiply node. Maybe drag this up here. And add a couple of reroute nodes. And we plug this into an add node. And then we can take this return type, plug it in here, and then that'll give us a return node automatically, so we can just plug in this value like so. And then the last function we need to write is just our offset. This one's pretty simple. It uses the small radius. So we'll hold Control, drag that in, and then we'll multiply that by -1. And then we can set this as our row offset. So Hexagon grid-based systems, you usually want to offset every other column or every other row, depending on your orientation. Basically just by 1, so they'll kind of hook in and like slot together nicely. And I'll show you how we set that up here now, actually. So we got all our functions written. Let's go back into our construction script, and we'll finish this off. We'll come to our first for loop. You'll notice our horizontal space now has an input and an output. We can feed in our index. So that'll basically take that index value and multiply it out. The reason we have to do that is because this thing is going to start from a corner, and it's going to like scale out. So it needs to be able to basically have a scalar value, so it's offset from the corner origin basically. And then we have the return value here that we actually want to plug. The horizontal space return type is actually going to go into the X value. And then I'm going to drag this down like so. Now the second for loop will pass the index into our vertical space. At the end of the vertical space, we're going to come into an add node, and then we're going to pass in our row offset, and then this is going to feed into our Y value on this one. And again, it's this way because this is the pointy top configuration, not the flat top. And then on the completed section of the for loop, we can come down into a flip-flop, and then under the A channel we can come into our offset function. Under the B channel we can just set the offset row to be 0. Now if I did that right, you can come in, hit compile, and you can see we have a nice little grid system. Let's go back into our world. Let's add our blueprint here. We can recenter it. And now you should be able to, in the inspector, you'll notice your public values that you exposed. You can adjust the width, the height, you can adjust the scale. Whoops, actually we forgot the scale. So let's reset that. Oh wait, no, maybe we didn't. No, it's working, okay. It's just taking a little bit. So you can adjust the scale there, and then you can also adjust the offset. Maybe do 6. Maybe make the scale back to 1. And you can see you can kind of space them out and get whatever design you're kind of looking for. Now normally your grid system won't be used as like a floor. You'll be likely using this as movement. But that's not the purpose of this video. We're just creating the tile system. We'll cover that maybe in a later video. One other important note I will draw to this though is this solution doesn't scale very well because it's using instance static meshes that we're creating from Blender. It's very expensive, so when you start going to like a really big grid system, you notice it'll start lagging and kind of hiccuping. What you can do is you can use this solution with a procedural mesh, and you'll have to define the hexagon points or the vertices and set the normals, and that'll be very, very performant. So you can do like bigger grids if you wanted to do that. But otherwise, I think it's pretty good for a basic starter system. Alright good people, we'll cut the video here to keep it short, but I hope you found some informative value that you can take into your own projects. As always, thanks for watching, consider subscribing, and we'll see you on the next one.